How does UV degrade plastic polymers? Have you ever wondered why some plastic items fade or crack after being left in the sun? The answer lies in ultraviolet radiation and its effect on plastic polymers. Let's break it down. Ultraviolet radiation, commonly known as UV light, interacts with plastic polymers mainly through a process called photo-oxidation. This process happens when UV light combines with oxygen in the air. When plastics absorb UV radiation, certain chemical groups within the polymer, known as chromophores, react to this energy. This reaction initiates a series of chemical changes that break the long chains of the polymer. This breaking of chains is called chain scission. As the polymer chains break apart, the molecular weight of the plastic decreases. This reduction leads to a loss of mechanical properties. For instance, the material becomes less strong, less elastic, and loses its ability to resist impacts. The degradation process starts when UV photons provide enough energy to break the chemical bonds in the polymer chains. This results in the formation of free radicals. These free radicals are highly reactive and can further react with oxygen, causing oxidative damage. As a result, the polymer structure weakens over time. You might notice surface erosion, discoloration, and even cracking. Discoloration often appears as yellowing, while cracking can lead to a loss of gloss and a powdery residue known as chalking. This chalking occurs when the outer layers of the plastic erode, exposing the fillers or pigments underneath. As plastics degrade, they can become brittle and more prone to mechanical failure. This often leads to fragmentation into smaller pieces, including microplastics. Environmental factors like wind and abrasion can accelerate this breakdown. The extent of UV degradation varies based on several factors. The type of polymer plays a significant role, as does the presence of additives. The intensity and wavelength of UV exposure are also important, with UVB light being particularly harmful. To combat UV degradation, manufacturers often add UV stabilizers to plastics. These additives can be ultraviolet absorbers, which absorb harmful UV radiation, or quenchers that deactivate excited molecules. There are also hindered amine light stabilizers that scavenge free radicals to interrupt the degradation process. These stabilizers help extend the life of plastic products that are exposed to sunlight, such as outdoor furniture and automotive parts. Understanding how UV radiation affects plastic is essential for grasping the reasons behind the mechanical breakdown of these materials. It explains why plastics that seem durable can become brittle and cracked over time. This knowledge is vital for designing better polymers and creating protective additives that can prolong the lifespan of plastic products while reducing environmental impact.